Imagine drilling deep beneath the red Martian surface and finding something that's been frozen in time for tens of millions of years. Not fossils, not bones, but microscopic traces of life, perfectly preserved in ice. New research from NASA and Penn State University suggests that if life ever existed on Mars, its chemical fingerprints could still be there, trapped inside the planet's frozen layers like a biological time capsule. It means Mars might not just tell us if life once existed, it could show us when it died and how long it's been waiting to be found. For decades, Mars has been the great mystery of our solar system. A world that seems both familiar and alien at the same time. Its rusty surface, towering volcanoes, and dried riverbeds tell a story that feels eerily Earth-like. Billions of years ago, Mars had flowing water, a thicker atmosphere, and possibly even oceans. It wasn't always the cold, barren desert we see today. Somewhere in that transition, something happened, and if life ever existed there, it may have been frozen along with the planet itself. That idea has now taken on new weight thanks to a study led by researchers from Penn State University and NASA's Astrobiology Institute. Their goal wasn't to look for life directly, but to answer a simpler question. If life once existed on Mars, could any trace of it survive? To test this, scientists created Martian-like conditions in the lab, the same freezing temperatures, thin atmosphere, and radiation levels that sweep across the red planet's surface. Then, they exposed amino acids, the chemical building blocks of life, to these conditions to see how long they could last. What they discovered was extraordinary. Amino acids buried in pure water ice remained stable for millions, even tens of millions, of years. But when those same molecules were mixed with Martian soil or exposed to radiation, they broke down much faster. The results suggest that ice acts like a shield, protecting delicate organic material from destruction. This means the best place to search for signs of ancient life on Mars may not be the dusty plains where rovers like Curiosity and Perseverance roam today. Instead, it might be underground, in the frozen deposits near Mars's poles or beneath layers of permafrost where ice has remained undisturbed for eons. There, the planet's biological past could be perfectly preserved, molecular fossils waiting in suspended animation. The discovery also reframes how scientists interpret previous missions. The Viking landers of the 1970s searched for organic molecules and found almost none. But now, it's possible they were simply looking in the wrong places, on the dry, irradiated surface, where any fragile chemical traces would have long since decayed. If life did emerge on Mars billions of years ago, its remnants might not be gone. They might just be hidden, buried beneath the ice, silently waiting. In the next part, we'll explore what these findings mean for the future of Mars exploration and how upcoming missions plan to dig deeper than ever before to uncover the planet's frozen secrets. If the story of Mars is frozen beneath its surface, then the next chapter of discovery will depend on how deep we're willing to dig. For years, NASA's rovers, Curiosity, Perseverance, and Spirit have explored Mars's dusty plains and ancient craters, searching for signs of past water and habitable conditions. They've found riverbeds, deltas, and minerals that could only form in liquid water. But even with all those discoveries, the one thing they haven't found is direct evidence of life. That's because Mars's surface is brutal, constantly bombarded by cosmic radiation and stripped bare by dust storms. Any organic molecule exposed to those conditions would be destroyed within a few million years. But beneath the surface, it's a different story. According to the Penn State study, amino acids buried under even a few centimeters of pure ice could survive for tens of millions of years, protected from radiation and the planet's thin, corrosive atmosphere. If life ever evolved on Mars, its traces may still be intact, hidden within those frozen layers. That's why upcoming missions are changing their approach. The European Space Agency's ExoMars rover, named Rosalind Franklin, is designed to drill nearly 2 meters below the Martian surface, deeper than any rover before it. Its goal: to collect samples from beneath the radiation-affected zone, where ancient biomolecules could still exist. NASA, meanwhile, is developing plans for Mars Sample Return, a mission that will bring pieces of the Martian surface back to Earth for detailed analysis. These samples, already being collected by the Perseverance rover, will allow scientists to search for chemical signatures of life with instruments far more advanced than anything that could fit on a robot. But to reach the real-time capsules, the untouched pockets of ancient ice, scientists may need to go even further. Future missions are considering the use of cryobots, small heated probes capable of melting through ice layers to search for trapped organics below. It's the same technology being studied for potential missions to Europa and Enceladus, two icy moons that might also harbor life beneath their frozen crusts. The idea that Mars could preserve traces of life in ice is both haunting and inspiring. It suggests that somewhere below the frozen surface lies a story billions of years old, the story of a planet that may have once been alive. And perhaps the most fascinating part, those traces wouldn't just tell us about Mars, they'd tell us about ourselves. Because if life could start there, under such different conditions, then life might not be a cosmic rarity at all. It might be the universe's natural state, frozen, waiting, everywhere. If Mars really holds the remnants of ancient life, locked in ice, preserved through time, then what we're about to uncover isn't just the story of another planet, it's the story of life itself. For decades, scientists have wondered, is Earth unique? Or is life something that the universe simply does whenever the conditions are right? Mars may hold the first real evidence to answer that question, and ironically, it might come not from living organisms, but from what's left behind, molecular fossils preserved in a frozen Martian tomb. These biological fragments, amino acids, lipids, or even degraded strands of DNA-like material, would be a record of a time when Mars was young, warm, and wet. If confirmed, they would mean that life began not once, but twice in our solar system alone. That realization would change everything. It would mean that life is not a miracle, it's a pattern, that wherever water and chemistry meet, biology may quietly emerge. And yet, what makes this search so profound is that it's also a search for loss, because even if we find signs that Mars once hosted life, we'll also be confirming something else, that it couldn't last. The planet lost its magnetic field, its atmosphere thinned, the temperature dropped, and the once flowing rivers froze solid. Mars became a time capsule of its own extinction. This duality, life and death, creation and preservation, is what makes Mars such a powerful mirror for us. It forces us to look back at Earth, a world that still has what Mars lost: a magnetic shield, a thick atmosphere, a warm surface, and life flourishing in every corner. But the same physical laws that froze Mars still apply to us. Change one variable, and even a living planet can fall silent. That's why missions to Mars are more than scientific endeavors. They're reminders of our fragility. When NASA's Perseverance rover drills into Martian rock, or when future missions melt through ancient ice, they're not just searching for microbes. They're asking one of the oldest human questions: how long can life last? And if we do find preserved traces of life, even a few organic molecules or chemical fingerprints, they will mark a turning point in our understanding of existence. Because those tiny frozen relics would tell us something extraordinary. That life doesn't just happen once in one place under perfect conditions. It happens everywhere the universe allows it. And so, the next time we look up at that small red dot in the night sky, we may not just be seeing a cold, empty world. We may be looking at a frozen memory, a record of what once was, and a reminder of what still could be.